Hello guys, we will look into another problem on centrifugal pumps here. So in this particular problem he says the centrifugal pump has an outer diameter equal to 2 times of the inner diameter. So if outer diameter is equal to 2 times of inner diameter, how will you write in the form of equation? That is outer diameter d2 which is equal to 2 times of inner diameter which is d1. Now he says it is running at 1000 rpm. So n is equal to 1000 rpm. Next, working against the total head of 40 meters. I told you the total head is nothing but the manometric head which is given, which is 40 meters here. The velocity of flow through the impeller is constant. Be careful about this. Velocity of flow is constant, he says. So if he says that, you have to immediately come to a conclusion that Vm1 would be equal to Vm2, and that is also given the value which is 2.5 meters per second. The vanes are set back at an angle of 40 degrees. So vanes are set back in the sense backward vane angle, it is set back at 40 degrees in the sense the outlet blade angle which is given as beta 2 as 40 degrees. If the outer diameter of the impeller is 500 mm, which is nothing but the value of d2, outer diameter is d2 no, so 500 mm in the sense that is 0.5 meters, okay, and the width is 50 mm, so I would be taking it as 0.05 meters, okay. 50 meters find. So what we need to find in this problem? So to find, number one, vane angle at inlet, so nothing but beta 1. Second one, work done by the impeller, nothing but the power developed. Third one, manometric efficiency. So all these three you have to find in this problem. So since he has clearly specified that it is set back at an angle of 40 degrees, that means that is a backward vane pump. So you have to draw a velocity triangles with respect to backward vane pump. Remember, the backward vane pump velocity triangle would be something this order. Okay, forward vane pump would be of something this order. Okay, you have to remember. And inlet velocity triangle would remain same for all the three cases. Okay, so that you have to remember. Let us proceed with the solution now. Solution. So first, let us try to calculate the value of beta 1. So as per the last problem, it is same tan beta 1, apply beta 1 in inlet velocity triangle, tan is opposite by adjacent, so it is Vm1 divided by U1. I guess the value of Vm1 is clearly given in the problem. You have to calculate the value of U1, that is also easy, that is pi d1n divided by 60, that is equal to, it is pi 0.25. You can calculate the value of d1 from this particular relation here. He says d2 is twice the d1, so d2 is 0.5, so d1 would be 0.25. Okay, so pi into 0.25 into speed is 1000, this whole divided by 60. So if you calculate this value, it would turn around 13.09 meters per second. Okay, now substitute here, it is beta 1 which is equal to tan inverse of Vm1. Vm1 value was given, which is 2.5 divided by U1, you have just calculated it as 13.09. So the value of beta 1 would be 10.8 degrees. Okay, so that's it for question number 1. Second, whatever he has asked is the work done, which is nothing but the power. We shall try to calculate it. So remember, please do remember this equation, that the power is given by rho kev u2 vu2. Rho kev u2 vu2 is the expression to calculate the power, and that you will get it in watts. So what I will do is I'll just change the color of this and say you to remember this. Okay, next let us calculate one by one. Rho is nothing but it is density of water, which is 1000. Q is not given, so we shall try to calculate Q. Okay, so how will you, rho is 1000, I'll just write it up. So rho is 1000 kg per meter cube. Rho is done. Next cube. Cube, how will you calculate? I told you either you can use A1 VM1 or you can use A2 VU2 VM2. It is of your choice. So let us take Q to be A1 A2 VM2, that is equal to. Now how will you calculate A2? That is an important thing here. So it is pi D2 B2. So this you have to remember again. Okay. Pi D2 B2, this whole into VM2. I guess VM2 the value is being given that, and B2 value is given and D2 value is given. So kindly substitute all the values. It would be pi into 0.5 into 0.05 into 2.5. So from this the value of Q would be 0.196 meter cube per second. So that is the Q value we have calculated. What else is remaining? U2. So I guess U2 is easy. It is pi D2 N divided by 60, that is equal to pi. D2 value is how much? D2 value is 0.5 into 1000 divided by 60. So that is equal to 26. U2 is equal to 26.18 meters per second. Next, you have to calculate the value of VU2. For that, you can use tan beta 2. So you have to calculate the value of V2. So you can use tan of beta 2. So tan of beta 2, if you apply opposite, it will be VM2 divided by U2 minus of VU2. So that is B2 beta 2 value is given. So kindly substitute it. It would be tan of 40, which is equal to 2.5 divided by 26.18, just you have calculated, minus of VU2. So from this you can get the value of VU2 as 23.2 meters per second. So since every value is being calculated, you have got the value of rho. Q is done, U2 is done, and VU2 is done. Kindly substitute all the values there to obtain the power. So power is equal to 1000 into 0.196 into 26.18 into 23.2. Now whatever the value you will get it in watts. It is 119.04 watts. So thereby you complete the second bit of the problem. Now the third one, which is manometric efficiency. So how will you calculate manometric efficiency? You already know that it is nothing but the manometric head divided by Euler's head. Manometric head is given in the problem as 40. Euler's head you have to calculate now. So Euler's head, I would just write it here, manometric head divided by Euler's head. Okay, so Euler's head is equal to U2 VU2 divided by G, as calculated in the previous problem also. It is 26.12 cross 23.2, this whole divided by 9.81, you will get the Euler's head to be 61.91 meters. So now you can calculate your manometric efficiency. Manometric head is given as 40. Euler's head you have calculated is as 61.91. So if you calculate this, your manometric efficiency would come around 0.646, which is nothing but 64.6%. So this is your manometric efficiency. So this ends the problem, but do not forget to write the result statement. Result is okay. For given pump, the inlet blade angle was found to be how much? 10.8 degrees, comma, developing a power of 119.04 watts with manometric efficiency of 64.6%. So there you can end your